The correlation coefficient, or also denoted as R, is defined as the measure of the strength of the linear relationship between two variables. Is that a linear relationship? If there is a linear relationship, then how good is it? What we need to do is to calculate the correlation coefficient. We will consider the following set of data. There are 7 pairs of data. Now, we need to construct 5 columns. The 5 columns consist of 5 variables. The 5 variables are x, y, x squared, y squared, and the multiplication of x and y. By looking at the table of data of hours of study and test score, we can fill in the first 2 columns with the variables of x and y. So, when we total up all the data in x and y, we will get the value of 22 for x and 500 for y. Next, to get the values for the variables of x squared, we need to square the values in the variable x. For example, 3 squared is equal to 9. So, the total for the values in the variables of x squared is 84. Next, for the y squared. For example, when we square the number of 80, we will get 6,400. So, the value for the total of y squared is 37,450. Lastly, for the variable xy. So, 3 times 80, we will get 240. We will do the same things for other numbers. Now, the total of xy is 1,715. Now, let's look at the formula. What we need to do is substitute all the values of x, y, x squared, y squared, and xy into the formula. Then, we will get the value of r, that is 0.89. The value of 0.89 indicates there is a strong positive linear relationship between the hours of study and test score. As the hours of study increases, the test score also increases. Now, how to interpret the value of R? There are 3 important points you need to pay attention to. First, the value of R is between -1 and 1. For example, if you calculate R and get the value of 2.5 or -1.3, then you know it is wrong. Second, the sign of R tells what happens to Y as the value of X increases. If R is positive, then the relationship between X and Y is a positive relationship. This means that when X increases, the value of Y also increases. An example of this is the number of hours study and test score. Next, if R is negative, then the relationship between X and Y is a negative relationship. This means that as X increases, the value of Y decreases. An example is the number of absence and CGPA of student. Third, the size or magnitude of R tells the strength of the relationship. The closer the value to +1 or -1, the stronger the relationship. The closer the value to 0, the weaker the relationship. If the points are really close to the line, then the relationship is strong relationship, and R is close to 1. If the points basically cluster around the line but almost scattered, then the relationship is a moderate relationship, and R is between 0.5 to 0.8. If the points are very far from the line, then the relationship is a weak relationship, and R is closer to 0. In conclusion, this is a guideline to interpret the strength of the relationship. That's all from me. Thank you!
Created using Powtoon.